Fake news detection using machine learning project. So, what is fake news detection means? Fake news spread on social media has been a well-known subject in recent years. Fake news or misleading or incorrect information can readily be shared on and distributed on social media, reaching a broad audience. For example, during the 2016 presidential election in the United States, a recent study indicated that around 40% of Americans utilized social media as their primary news source during the campaign, far outnumbering print and radio. False information about the two presidential contenders, Donald Trump and Hillary Clinton, was posted millions of times on social media, according to the same study. Similarly, greater misinformation campaigns involving COVID-19 were uncovered in the US presidential election campaign of 2021. So here we are using layer dataset to detect the fake news or real news. So yeah, we have the layer dataset contain three different datasets, which is train, test, and valid. This dataset is already splitted into three different types of test, train, and valid. So I have loaded this dataset in my Google Drive. So here I'm active, like I'm contacting my Google Drive through Google Colab. So I'm importing pandas and NumPy libraries, and here we are importing RE library. This is for regular expression searching for data. What is RE? RE is regular expression. But why we are using this RE in our project? So we have to detect the news using the text or some paragraph or some big sentences. So for that, the RE useful for searching the text in a document. Next, this is the NLTK corpus import stopper. What is NLTK? It's a natural language toolkit. So, corpus is collection of text stored electronically that can be used to discover information about language that may not have been noticed, like content of the text. So, using NLTK corpus, we are importing stoppers. So, this will explain later. And next, we are importing photo stemmer using NLTK importer. Why we are importing photo stemmer? Photo stemmer is removes the prefix and suffix of the word and it will return the root word of the word. For example, there is three words called teach, teaching, and uh, teacher. So the root word is teach for that. So the photo stemmer do the removes those prefix and suffixes and that will provide the root word. The next is we are importing TF-IDF factorizer using sklearn feature extraction text. This is what is the TF-IDF factorizer? TF-IDF factorizes convert the text into feature vectors like numbers. We have to input the textual or sentence data, so that machine could not understand that text. So we are transforming the text into numerical data like feature vectors using TF-IDF vectorization. And then we are importing accuracy code to predict the accuracy. And then we are importing matplotlib for plots and Seaborn is as SNS for plots and plotty as plots. So our data, I'll show you the data set. This is our test data. So as you can see, there is no labels here. There is a completely raw data, and in one row we have different columns in one cell. So we have to divide this data into different columns. So for that, I have named our data as ID, label, text, subject, speaker, speaker's job, state info, party affiliation, barely true, false, half true, mostly true, fancy and context. So I have labeled these data. So first I have stored the column names in the column variable, and then reading the data from my Google Drive. So here I have given the path of my Google Drive and the file name. Here we are using separate is equals to, this means tab. Why we are using this? Because, for example, if you see the data, we have a tab space for every different column. So for every different value. So to differentiate these values into columns, we have to separate using separate tab. And next, header none. Header none means pandas automatically assign the first row of the data frame to the, which is actually column names to the first row. Hence, your column no longer have names. So here we don't need any header. So that's why we are making it as a none. And the names we are importing these column names is in names variable, like names is equals to column. This will create a generate a names for the our columns. So here we have loaded our entire three data sets, and we can see the all data sets. This is the train data. We can see the same column, same data. Here test data. So same columns and same type of data. Here also valid. So yeah, as we can see, we have same columns and same name label columns here, and same thing in just the entire dataset has been divided into three datasets. So now we can see the shape of the three datasets. See, train dataset we have 10,240 rows and 14 columns. For test dataset is 1,267 and 14 rows and 14 columns. For valid dataset it is 1,284 rows and 14 columns. So now I am concatenating these data frames into a one data set because we have to predict. I don't want to use the exact data set. I want to split in my own way into test and train data, so that I want to concat everything into one data set. So here I am using concatenation method to concat three data sets. And so here we can see that these are the JSON values as the ID. So for our dataset, I really don't want to use this JSON values. So yeah, I am dropping this column, ID column. After dropping the ID column, we can see the remaining data here without ID column. And next, the data cleaning process. In the data cleaning process, we have to see whether we have a missing values or not. As we can see, we have a missing values like none. So from this is null function, which we can see the sum of missing values in each column. So here in speakers job title, we have these many missing values. In state info column, we have 2,749 missing values, and in context column, we have 131 missing values. So total, we have 6,463 missing values in our entire data frame. Now, I want to drop those missing values rows, entire rows. I don't want to drop those columns now, but I want to drop those rows because we have enough data to predict. So this is a very large data set, so we can drop the rows. I have dropped the rows and we can see the count of the missing values. Now we can see 0. We don't have any missing values in our data set now. And then we are using ordinal encoder for label. In label, we have the prediction like barely true, false, half true, mostly true, and pants on fire. So I wanna make these text values into a numerical value. That's why I am using ordinal encoder. Ordinal encoder is the great method which can convert the text data into numerical data for analysis part for the great predictions. So for here I'm taking the label column and just I'm transforming these label column into ordinal encoder, and then I have got the float values in label column. So I just don't want to float values, I want to int values. So I just transform this float type into int type using as type method. Now I have plot a variable. I have plot label column. So I just wanna see how many true news we have, how many false news we have, how many barely true news we have. So here we can see, as per the numerical data, this is the values of our label. So for barely true, it's a the value of barely true is 0, the false is 1, for half true is 2, for mostly true is 3, for hands and file is 4, and for true is 5. So there is a above 2500 for half true values, and there is above 2000 for true values, and there is barely true values around 2000, and the minimum value is pans on fire. And now I just wanna see how which type of subject of context we have. Like we have different text, but the subject we have, like what is the subject? Like we have subject on alcohol, welfare, women. So as we can see, I have grouped subject and text. Wanna see how many different types of subject we have as per the count. But I can see there is almost 4534 subjects, different subjects. For alcohol subject, we have 5 text data, and for this welfare subject, we have 14 data. So I just want to use these data, these type of data for our exploratory data analysis. So I just want to take only text data to predict the value. So I just dropped entire columns. These subjects and speaker job titles, these I don't want to use. We can predict only using text values. But why I am dropping these barely true, fair, true, most true, and unfair values? Because as you can see, there is a calculations here. These are the count of our label. So for example, here is it's 3 means it's a half mostly true. So we can see 163, the highest count for mostly true column. And another column it is very less count. And we can see that 2 here, 2 means, here 2 means half true, right? For half true, as you can see, 20 is the highest count in half true column, and the remaining we have less count. So we really don't even want to use these, because these are the higher, these are the counting. Just we don't want to predict these values. We just want to predict what is what. Like for this text, is this true or is this false, or this half true or this is barely true? Just we want to predict these one. So I just dropped entire columns, and then I have created one data set with the remaining columns. So I named it as a final data set, and to CSV method, I have saved this final data set into my Google Drive. I have used index is equal to false, because this will does not create the index. Otherwise, it will automatically create another index column here. So I just I don't want that index column. That's why I used index is equals to false. And I am reading the data in final data variable from my Google Drive. So I just want to see the tail part of the data set. So yeah, we are left with the label, text, speaker, and context in our final data set. And then here comes the stop words. So yeah, what are the stop words? Stop words are, so here where I'm printing the stop words like I, me, these all are stop words. So in my data, I don't want these stop words for the prediction. Why? Why? Because stop words doesn't add much value to the paragraph or vertex. So this is very insignificant value. So if you have these values, you can't even predict the accurate results. That's why we have to remove these stop words. For that, we have to import the NLTK. NLTK and download function, we have to download all stop words in our file. And then here we can see these are the stop words we have to remove from our textual data. So after removing for that purpose, we have to stem. Stemming means this take a word and remove the prefixes and suffixes, and then return the root word of it, right? So for that we are using the port stemmer. So I am storing this port stemmer method in a port underscore stem variable. Now I am creating a function called stemming. Here I am passing an argument like statement, whatever it is, we can We can make it like the input value. This is the input value. So this is the stem mode content. I have created one variable. Here I am using re is equals to sub. Re means regular expression. So here using the regular expression sub function, what it will do? It will take a parameters of this one, the first parameter, what you have to replace. Which one you have to replace with what in which statement. Like I want to replace these values with the space in my input data. So this function will search for this is a exponential symbol. Exponential A to Z and capital A to capital Z means I just want to exclude A to Z, small a to Z and capital A to Z, and I just want to remove all the remaining punctuations, commas and space, and then in those place I just want to add space in whatever input I am giving. So yeah, here because in the textual data we can have so many punctuations or stop words or so many insignificant words that really we don't want to use. So I am excluding all the characters like punctuations and some special characters except these alphabetical things except alphabetics. I am removing everything here in this function. So I'm storing these values in stemmed content, and then I'm lowering the we can even have uh, capital values in our context. So I just don't want those capital values because the capital letters also sometimes it will give the wrong predictions. It will also sometimes insignificant for our model. So I just want to lower all our alphabets in my stemmed content variable, and then I just want to split every word in my stemmed content variable. So after splitting, I am using port to stem dot stem of word. Port to stem will call the port stemmer method. It will stem like it will remove the prefix and suffix of your word. Like here we are making our text into list, and we are splitting as a list, and we are taking every word from the word. We are taking if for word in stemmed content. We are taking every from word from the list, and if and we are deleting the stop words. Stop words that words of English means we are using the English language here. So we wanna delete English stop words. So we are here we are mentioning the English. So if the stemmed content is not having the stoppers, and then we have to store these words into again stemmed content variable. So if any stop word is here in the word, so we are not storing here. I mean we are deleting here, and then we are adding the space of each word and joining. We are in before we have splitted every word, right? So that we have splitted the data. So we are joining again after the stemming and porter stemmer, right? So now this is our raw content. I mean this is our stemmed content. Now finally we have got our clean root stemmed content. So we are returning our stemmed content here. So what we are saying here are we want to give input as a text column. So here I am stemming my text column. This is the final data that from the final data I am saving the and I am saving my stemmed content in my data itself in my text column itself. So I am applying stemming function for my text column here, and then as you can see it will take few seconds to for apply the stemming function for each and uh, every every row in the text column. So it will take some time. to apply the stemming. Now it's to 31 seconds to complete. Now our data is ready. So I'm printing the text file. So you can see the data finally. There is no see, you have active. There is no prefix and suffixes, and there is no special characters. There is no numbers. Only alphabets we have with the lower alphabets, not capitals also. Now we are seeing what is our data types. Label we have changed it to that remaining are all objects. Yeah. So we have to predict these values. True. What is true means? True means the state if the statement is correct and nothing important is lost. What is mostly true means the statement is correct but further information is clarification required. What is half true? The statement is partially correct, but it is fails to mention the key details or places information out of context. Barely true. The statement contains certain truth, but it leaves out important details that will provide a different image. False. The statement is wrong. Hands on fire. The statement is incorrect and make an outrageous claim, that means liar, liar, pants on fire, exclaim the speaker. So these are our dependent variables. So now I just want to store our dependent, independent variable values in X and Y. So I just want to this this text. I just want to use this text column for prediction to predict this label column. So this is my independent variable and this is my target dependent variable. So here I am using ilog function to locate the locate the location of the my independent variable text column in final data, and I'm storing the values of the text column in X variable, and I'm storing the values of the label column. 0 indicates the first column, it's a label column. So I'm storing this in Y label. So printing, you can see that this is my X and this is my Y variable. Now I just want to see what type it is, just is it stored as a numpy in the array. So now I want to split data into train and test data. So I just want to split, we can split into 75 and 25% and 80 and 20%. Now here I am using 0.25 means it's split our data into 75 and 25%. That's okay, whatever you can use. So this is the this is my X variable and this is my Y variable. I just want to use these variables, and the how much I just want how much I want to split the data. This is the size and the random state. Random state is equals to 0 means we can place anything in the random state value, like it can be 0, it can be 1, or it can be anything. So I just kept as a 0. So the train X train X test, Y train Y test. In X train X test, we have the 75% of the data. In Y train, sorry, in X test and Y test, we have remaining 25% of the data. So the X train contains the values, and the Y train contains the labels of the X train. Now I am using TF-ID vectorizer for transforming the my textual data into numerical data. So only we have to apply this on our train and test data. So I have created a variable called vector, and here I am calling the I'm loading the tf idf vectorizer function here. So I'm calling another method called tf underscore feed. Here I'm fitting the extract data in this variable using using tfid vectorization, and then I'm first I'm fitting this variable, and then I'm transforming my train data, and then I have to transform the test data as well using this vectorization. Yeah. Next, just see the shape. Here is the shape of our train data. Next, the models. So here what I have done is I have created a function. In function, I have used three models. So we can use any model we want by using an index number. Like for these models, I have named it as a model for this function, and I'm passing two arguments like xtrain and ytrain. First model I am using here is logistical model. For logistical model, I have imported logistical regression using SQL and linear model. Why we are using logistical model? Because this is a binary classification, like you have to predict only one or two or three or like four or five. So that's why it is very important. I mean, this is very familiar to use these type of regression model for the binary classification output. So here, here also I'm using like random state is equals to 0, because this is to check and validate the data when running the code multiple times. Like setting random status is like for a fixed number, a fixed value will guarantee that same sequence of random numbers will are generated each time you run the code, and unless there is some other randomness present in the process, the result produced will be same as always. This helps verifying the output. That's why always I am keeping random state is equals to 0. If you wanna keep one, just use one. That's okay. If you wanna keep sometimes typical coding, so many I have seen some codes like they are using random state is equals to 42 or 32. That anything is fine. So I'm just loading my regression model into variable, and I'm fitting my train and text data, like sorry, I mean xtrain and ytrain in this model. And same thing, I am using decision tree model for the decision tree classifier. Same here, criterion is entropy. Why I am using decision tree classifier means it will creates the classification model by building a decision tree. Each node in the tree specify a test on an attribute. Each branch descending from that node corresponding to one of the positive values for that attribute. So yeah, and the criterion is equals to entropy, means it's entropy measures the quantity of a split, and it allows users to choose between gain or entropy. Like it will calculate the gain and use info gain to split a node. So yeah, here we have to use entropy for the criterion. This is the important parameter in decision tree. So I am fitting my training data into decision tree model, and at the same time I'm using one more model called random classifier, random forest classifier. Random forest classifier means it is a multiple decision trees, and merge them together to get a more accurate and stable prediction. So here also we have to use the entropy, because it will use the info of gain and to split a node. So here we are using n estimators is equals to 10. Why? The n estimators means the number of trees you want to build before taking the maximum voting or average of predictions. Higher the number of trees give you better performance, but makes your code slower. So I'm fitting the train data in random forest model, and here I'm calculating the accuracy score of each model. So I have created each variable. So now I'm calculating the score for each model, and I'm returning the three models here, and I'm loading three models into a variable like an array. Here I am passing my extent transform using TF-ID with ID of factorization and my Y tray. And I'm printing MD. So you can see what is MD. What is MD? Storing values. How you can see how this MD variable storing the three variables. So now after running this, yeah, you can see the accuracy of the logistic regression is 74. For the decision tree is 99.9. For the random forest 99.8. So as are printing the MD, so yeah, here the MD is storing all three models in an array. Yeah, in a tuple. Now we are using confusion matrix for the predictions. So what is confusion matrix? Actually, confusion matrix will give you a true positive, true negative, false positive, false negative results. What is true, false positive, true negative? Like what is all this? For example, one person have a disease and we are predicting it. Okay, for example. So what is true positive? If the person has a disease, we are predicting yes, it is called true positive. If the person has a disease, but we are predicting no, it is a false. It's not correct. False positive. False negative. Sorry. And if the person don't have a disease, but we are also predicting no, like correct. We are predicting correct. This is called true negative. If the person don't have a disease, but we are predicting this, uh, yes, it's called false positive. So yeah, this is the confusion matrix. This will give you a matrix format of the count of like this. We are predicting 0 and 0. It's predicting the count. We can see the count here. So here we are running all three modules. We are taking the length of the modules and we are running all three modules. We are taking the Y test. We have to use here the test data. So we are looping our models, and we have to predict each model using X test. Now this is the formation like matrix. We are storing the values, these true, negative, true, positive in this format. So now the testing accuracy. What is like how you are calculating the accuracy using confusion matrix means uh, adding the true positive and true negative with average of like by true positive plus true negative plus false positive plus false negative. This is the formula of accuracy in confusion matrix. So using this formula, now we can find the accuracy results of the test data. Now we are here importing the our test data and we are calculating the models accuracy. See, the corner values are true positive. So you can see the values. How many true positive? For 0 and 0, it's predicting 400. 1 and 1 and 2 and 2. Yeah. This is for logistic regression model. For the model 1, this is the model 1 means it's a decision tree model. For decision tree model, just see the values 745. This is a bit more higher values than the logistic model, and the accuracy I'm sorry. And the accuracy for the logistic model is 84 in test data, and for the decision tree is 98, and for random forest is 98.7. For decision model, it's a 98.6. So we can compare the confusion matrix for the decision tree and the random forest classifier. So yeah, we can see the value 745, 750, 976, 987, 950, 951, 1018, 1003. So here we have like bit more values than compared to the decision tree model, and the accuracy also just 0.1% higher than the decision tree model. So that's why I just wanna use the random forest model for my prediction. Now I have used random forest model for my prediction. Now here I am printing my prediction values. These are my prediction values 133 ending with 102. These are my actual values. These here I am printing the y-test. Here I am printing the prediction values. So yeah, almost same because it's a 98.7, almost the same. Just we can be miss one or two values, but almost every value we are predicting correctly. Now we have to apply our prediction to our input data. Here I have used one function name called news data. I'm passing the news, like I'm passing the input here. So I'm storing, so our input will store in a list format here. So why I am doing this? Why I am doing this? Like here I am making a name called text and I am storing these list values like it looks like a dictionary, right? So what I'm doing here? Here I am doing our input data, taking our input data and making it as a column in a data frame. Okay, why? Why? I'll tell you. So here I am taking the input value and this is in the list format. So because ours is like sentence or paragraph, so I just want to take is the list format. So I am storing our data in a column, like in a column. So here I have take another variable. I am using pd.data frame input data. This will change this dictionary to a data frame. Now here this will look like a data frame. The text is a column name and the news is a row in a column. This is the we have created a data frame using this code. And now here I am applying stemming. Why? Because while doing prediction before applying machine learning models, we did stemming part to get the accurate predictions because it's a categorical value. Now we are also passing the same in text data as an input. So yeah, so to apply those prediction models, so we have to do the stemming part to our input data too. Otherwise, we're not going to predict exact same values. So for any string value, for any list value, so for any int value, we can't apply this stemming method because there is no apply available in our list or string. That's why we are doing this part. Now this is not a list, not a string, not a int. Now this is a row in a data frame. This is a column. This is a column in a data frame. Now we are applying our stemming function to a column. This will work after application. So yeah, this will remove all punctuations, stop words, everything. So now it's a clear data. This data we are storing into a variable called text. Now we have to transform this text as a numerical machine understandable way. For that, already we have created one variable called vector. In this variable, we have already stored tfid vectorizer. TF-ID vectorizer here. Here, this is a vector. In this, using this variable, we are transforming our text data into a numerical value and we are storing this data into a vectorized data variable. Now we are passing this as a passing this as an argument in our model and we are predicting this data. So we are using prediction method. We are predicting our input data with MD of 2. This means random forest model. So this is the index 2. Index 2 represents the random forest model here. MD it stores all the models. So the 2 index represents the random forest models. We are predicting our input data using the random forest model and we are also printing the prediction. So we have 5 different values here like barely true, false, half true, mostly true, pants and fire and true. So after prediction, if you get these values, we have to show the results as this. For example, if our data is our text is true, so we have to send this news is true. For example, if you pass other data other than in the list, we have to print these value like this news is not listed in the data. So yeah, now running this code and I'm passing. See, this is predicting 5 and the printing this news is true. So this is just index value. Don't bother about this. Yeah, this is our result. You can see other also taking the random test. Like, see, this is barely true. So we have to get barely true result here. So half true. That's okay. Our data is like 90 or 98%, not 100%. So yeah, sometimes this will not predict properly. And I take simple. Oh, this is other data, I guess. Yeah, this is. Yeah, we are getting different results here. So our main motive is we have to get these results in our WhatsApp chatbot. So what is WhatsApp chatbot? Like other chatbot, but if we send a news data, we have to get the prediction in WhatsApp automatic response. So yeah, how to connect with the WhatsApp chatbot? To connect to the WhatsApp chatbot, we can't integrate the WhatsApp and everything with a collab. So I have downloaded my entire file and I have saved in one, like I have created one my .py file here. I have pasted entire my code except print values because I don't want to print again here. So just I have removed all print statements and just I loaded the data here. And I have pasted my 3 dataset in the same folder. This is the ng and this is my main file, chatbot file. So yeah, here this is all our collab data, same values. Yeah, for WhatsApp chatbot, what we need? We need first Flask. What is Flask? Flask, it is a it will create a chatbot API using a Flask. Like it's a web application. So using Flask, we have to create our WhatsApp chatbot. And what is Twilio? Twilio is a platform. So using Twilio, we have to create a sandbox. So through the sandbox, we have to send our messages and get the response. Through this, we are importing messaging responses here. App is equals to class. This code means, this line of code means, here we are starting our app. We are initializing, like we are starting our Flask app. Now, at the rate app.root slash SMS method post. So our method should be post. And what is this? Here we are routing our SMS function. So this will follow the SMS function. This will call the SMS function in our host, like in our server. Input data, same text. I have copied from the uh, no, Jupyter notebook, but here I didn't use like As you can see here, I have used news like only list everything, but here I am using request.values.getBody. Why? Why? Because our WhatsApp contains a body. So we are requesting what is the input we are sending in our WhatsApp that is sent into a body. So we are getting that uh, response. We are requesting that input from the body, and we are taking like we are lowering all alphabets into a lower values. I mean, even capitalized, we are removing capitalized things and we are making it lower. And then we are storing everything in input data. And this request function is used to get the data from our WhatsApp chat. And response, we are creating a variable for the message response. If after sending a message in WhatsApp, you have to get automatic response. For that purpose we are creating this message response function. This is the built-in function. We can use this. And this response dot message, this contains some built-in parameters. So this will create, like you can see, so body to from action. So with this, we can get the response from our code in WhatsApp body. Now, so exact same data, we are creating our input data as a data frame, and then we are applying stemming, same thing, and applying vectorization and applying the prediction using the random forest classifier model, and then we are predicting our values here. And we are returning the response. In response, we have the result. In response, we have the result. We are storing our results in our response, and that is string format. That's why we are uh, uh, returning our value in string. So that will return the string text in our WhatsApp chat. So instead of print statement, here we are using message.body in every line. Why? Because our WhatsApp contains a body. So if you write the print, we can see that uh, result in our console but not in our WhatsApp chatbot, right? So if you want the result in WhatsApp chatbot, you have to use the message.body function body to get the response in WhatsApp. So here this is our main method, and we are running this method here. For this, we have to use ngRock. ngRock is an application, so we can use this ngRock for the temporary hosted URL, as we have to see the results using our temporary server and temporary URL. So we need the temporary host URL. That's why we are using ngRock. So just download ngRock in your system and store wherever you want, and create an account for Twilio. For I have already have an account in Twilio. First, I am running this code. So while running, it will automatically save my final data set in my folder itself. Here I am running. So yeah, now you can see here. Yeah. Now we got the local URL. See, this is nothing. If you pass our method, it will show method not allowed, but this is a local URL. So here, this is the 5000 is our port. So I just wanna create hosted URL. Here I have downloaded my ngRock in my file itself. Here I am opening command prompt. In command prompt, just check your ngRock is in your system or not. So yeah, I have ngRock in my system downloaded. So this is the result if you have your ngRock downloaded. So now I just wanna host I just want to get the host URL. For that, you have to write a command called ng-row http. Our port number is 5000, right? Yeah, 5000. Enter. Now here you got your hosted URL. This is the hosted URL. Just remove this and paste here. You will have to get the same response. Here we have started our server. This is our hosted URL. So now we have to create a sandbox for using this URL for our WhatsApp. This is Filio. I have already have an account. So I'm just logging with my account. So just go to Twilio and just create your account and create a sandbox with your WhatsApp number. This is messaging. Give me a messaging. Try it out. Send a WhatsApp message. I have already created a sandbox. So this will give a code. If you send this code, your WhatsApp chat bot will get activated, like connected. So yeah, here you can see you are all set. The sandbox can now send and receive messages. I have created my WhatsApp chatbot sandbox. Now after this you have to do all these steps. Yeah, next you are ready to go. Here you have to paste your host URL with the SMS with our method. So that host URL will run our method /SMS and save. Next, this is our WhatsApp chatbot. So let's try this text. This is a pants fire, right? Send. This news is false. Oh yeah, I'm ready. Mostly true. See, as we don't have 100% accuracy, we could not expect every prediction should be true. Here, sometimes we'll get false, sometimes we'll get true. As our prediction is like 98%, we can get only less few predictions correctly. The half true, false. This is true. See, it is getting better, good predictions. So yeah, this is our WhatsApp chatbot. So we can use deep learning. We can even improve this better using deep learning, neural networking, using some pickle, pickle libraries or pickle files, and like some pipeline functions and some TensorFlow. Using so many, we can use so many different things for our further in future. If you want to predict much more, like if you want to use so many CHS as the independent variables and you want to predict this accurately, you can use these, and you can use natural language processing, so that will give you good predictions for the future. Thank you.